Greetings of the day, dear students. In this video, we are going to discuss about the AC power supply schemes. What are the different schemes we are having? How to supply the power once it has been generated? How it is to be supplied to the customer? What are the different systems we are having, like DC or AC system, overhead or underground system, and what are the different components present in the AC power supply scheme, like generating stations, primary transmission, receiving station, secondary transmission, substation, primary distribution, secondary distribution. Like this, we are going to discuss the functionality of each and every component, the purpose of each and every component, from which voltage level to which voltage level is to be called as primary transmission. If it is secondary transmission, what are the voltage levels? Like this, we are going to discuss about primary distribution and secondary distribution, and also we are going to compare the DC and AC transmission system. What are the advantages we are having in DC transmission system? What are the disadvantages in DC, and advantages of AC power supply scheme, and the disadvantages of AC power supply scheme. And also at the end, we are going to compare the overhead lines and underground cables. And while comparing these points, we will come across some three terminologies like skin effect, corona, and proximity effect. We are going to see what do you mean by this skin effect, corona, and proximity effect in this video. Dear students, before watching this video, we have completed the different ways or means of generating the power, like hydro power station, thermal power stations, and solar, wind, and all those things we have completed in the previous videos. Once the power has been generated, the next task is how the power is to be transmitted over long distances and how it is to be distributed. So here the three major components with respect to the electrical power are: one is the generation, second one is the transmission, and the last one is the distribution. How the power is to be generated, how the power is to be transmitted, and how it is to be distributed to the consumer or to the customers. So these are the three major components with respect to the power generation, transmission, and distribution with respect to the entire power system, dear students. While doing this process with respect to the generation, in the previous videos we have seen how it is to be generated using hydro power plants, using thermal power plants, using coal or gas, and using solar, how the power is to be generated, or using wind energy, how the power is to be generated. And also we have seen how the power is to be generated using the nuclear power. The next task is the transmission and distribution. Here the power generated can be transmitted. We are having DC system or AC system, overhead or underground system. Most of the times the transmission will be carried out using 3-phase 3-wire AC system. This is very important. It will be transmitted using a 3-phase 3-wire AC system. This is most commonly adopted, and also it is economical. Whereas coming to the distribution of power to the consumer or to the customer, it will be done with the help of 3-phase 4-wire AC system. So the important point is the transmission is carried out using a 3-phase 3-wire AC system, and the distribution of power will be carried out using a 3-phase 4-wire AC system. Again, here we are having underground and overhead system. Out of these two things, the overhead system is most commonly preferred because the underground system is very expensive, and also protection wise, maintenance wise, and with respect to handling the insulation levels and transmission of high ratings of power at higher voltage levels, we will come across some problems with respect to the efficiency and losses also, right? Because of that, we used to prefer or opt for the overhead transmission system. Now, with respect to the different components, dear students, the very important point is, once the power is generated at the generating station, and while transmitting this power through transmission towers for long distances, it should be carried out at higher voltage levels. Higher voltage levels. Again, while utilizing that power, the voltage levels will be stepped down. The voltage levels will be stepped down. So here, at generating station, once it is generated, the power is generated at 11 kV voltage level. With the help of step-up transformers, this 11 kV voltage will be stepped up to 132 kV using the power transformers. Once it is stepped up to the 132 kV, and it will be transmitted over the long distances. Sometimes it can be greater than 180 kilometers also. The generated power will be has to travel sometimes greater than 180 kilometers also in order to reach the customers or load centers, right? Now, once it is stepped up to 132 kV, and again at just before the receiving station, this voltage levels will be stepped down. Now this 132 kV is stepped down to 33 kV. So this part will come under primary transmission, and from receiving station, which will be located at the outskirts of the city, right? From there onwards up to the substation, we will treat it as secondary transmission. Now during this secondary transmission process, now the power is being transmitted at 33 kV voltage level. The power will be transmitted at 33 kV voltage level. Now once it has traveled after some distances, again now just before the substation, right? Now this 33 kV will be stepped down to 11 kV. 33 kV will be stepped down to 11 kV. Now this 11 kV again will be further stepped down to 400 volts. Now this 11 kV indicates the three-phase voltage which is in between the two lines, For example, if you want the phase voltage value will be line voltage divided by √3. So already the line voltage is given, it is 400 volts between any two lines. We are going to have three phases or three lines. One is R, Y, B. If you take or if you measure the voltage between any two lines, that is to be called as line voltage, V line voltage, which will be around 400 volts. If you want the phase voltage, the relationship between the phase voltage and line voltage is the phase voltage will be equals to line voltage whole divided by √3. So like this, we are once it has came to the step down to the 11 kV by 400 volts, right? It will be given to the consumers. Dear students, here we are having four major components. One is the primary transmission, secondary transmission, primary distribution, and secondary distribution, right? Now the generating stations, as we have discussed here, the generating stations will generate the power at 11 kV and it will be stepped up to the 132 kV using the three-phase transformers, right? And the power is to be transmitted at higher voltage levels in order to save the conducting material, and also in order to have high transmission efficiency, they will be transmitted at higher voltage levels. If the voltage level is low, dear students, what happens is, to transfer the same amount of power, for example, if it is 100 kilowatt, if you want to transfer this power for the long distances, right? If the voltage is only just 11 kV, the current will be high. If the same power, if you transmit it at 33 kV, if you distribute the voltage rating, if it is increased, the current rating will be decreased, because the power will be constant. V and I will get adjusted in such a way that if V is high, I will be low, or if I is high, V will be low. If greater magnitudes of currents are passing through the line, I square R amount of power will be lost. I square R amount of power will be power loss. If losses are more, the efficiency will be output power by input power. So here, if the losses are more, the output power will be less, the efficiency will be less. So in order to minimize the losses, the power will be transmitted at higher voltage levels, where R indicates the resistance of the line. This is important. That is the reason why they will be transmitted at higher voltage levels. So dear students, this 132 kV is transmitted by the 3-phase 3-wire overhead system, right? Now the secondary transmission, that is the part which just gets terminated at the receiving station, and this will also visually be at the outskirts of the city, and now the voltage will be reduced to the 33 kV by the step down transformers, right? The part will come under the secondary transmission. Here, with respect to the primary distribution, now the secondary transmission is going to terminate at the substation, right, where the voltage will be reduced to the, just we have discussed earlier. So 33 kV will be stepped down to 11 kV, and this also will be under 3-phase 3-wire mode, right? Now the 11 kV line will be, this is the line which runs along the roadsides of the city, right, and this is going to form the primary distribution. Now if the customer is having more demand or more load requirement is there, directly he will be supplied power from the at 11 kV voltage level. Instead of stepping it down to 400 volts, the same 11 kV voltage level line will be given to the big consumers, right? Now the secondary distribution, here the power from the primary distribution line, that is will be delivered to the distribution substation. Now this 11 kV will be stepped down to 400 volts, and now here this will be carried out with the help of 3-phase 4-wire system for the secondary distribution. Clear? Right. So this is all about the primary transmission, secondary transmission, generating stations, primary distribution, and the secondary distribution. Voltage levels are important, dear students. In this single figure speaks about everything. The generating voltage is 11 kV. It is stepped up to 132 kV, and it will travel some distance at 132 kV voltage levels, and again it will be stepped down to 33 kV, and again further it will be stepped down to 11 kV, and again it will be stepped down to 400 volts. Dear students, in order to transmit the same amount of power, if it is a DC transmission, what could be the advantages we are going to discuss. If you observe, if the power is to be transmitted using DC, just we are going to have only two conductors, one is the positive and negative. But whereas for AC system, we are going to have three lines R, Y, B in order to transfer the same amount of power. So here the DC is going to require only two conductors, and moreover, with respect to the DC concept, between the two lines there won't be any inductance or capacitance or phase displacement problems will not be there. So that is one added advantage. If it is AC, the lines itself are going to have, even though it is a conductor, by default they themselves are going to have some resistance and reactance for the line. And again in between two lines, because of current flowing and the flux established around the conductors and the insulating material between the two conductors acting like a dielectric medium, some capacitance effects can also be observed. Even though physically there won't be capacitor, it seems to be like a capacitance effect can be observed if it is AC. So here there won't be no inductance, capacitance or phase displacement problems will not be there if it is a DC transmission. And moreover, dear students, once the bulk amount of power is to be transmitted for long distances, what happens is, for example, if distance is some 180 kilometers it is to travel, even though here if you are giving some 132 kV, if this is the sending end voltage, by the time it reaches the receiving end, it should be 132 kV. But practically, because of the resistance and reactances of the line, some voltage will be dropped. There will be voltage drop in the line. So because of the absence of this inductance and all these effects, the voltage drop in, if it is DC transmission, the amount of voltage drop by the time it reaches the receiving end point, the voltage drop will be less. But if the same amount of power, if it is transmitted using AC, the amount of voltage drop will be more. The amount of voltage drop will be more. So indirectly it is having a good voltage regulation if it is a DC system. And also, dear students, there won't be any skin effect in the DC system. I will tell you what do you mean by skin effect. If there is a conductor like this, if there is a current passing through this conductor, if the current I is passing through this conductor, depending upon whether the current is AC, alternating current, or DC current, right, the amount of cross-sectional area occupied will be varied. How much amount of cross-section of this entire conductor size, of this entire conductor cross-section, if it is AC, the current is going to be concentrated more on over the surface of the conductor, instead of across the. So the current flow will be higher over the surface of the conductor instead of at the center of the conductor, right? So it is the tendency of the alternating current to concentrate nearer to the surface of the conductor. Such a tendency is called the skin effect. Because of this, the AC current will not be uniformly distributed over the conductor, whereas if it is the DC current, the DC current distribution in a conductor will be uniform. But whereas the AC current distribution in a conductor will not be uniform. Its tendency will be more over the surface of the conductor, right, than the current flow in the center of the conductor. So this is called the skin effect. In DC system, the skin effect will be less, or there won't be any skin effect. That is also can be observed. And the corona loss in a DC system will be less. If the same amount of power, whether the current is the flowing is IDC or the current is AC, the surrounding air around the conductor will get ionized. Around this conductor, which is open to air particles or air molecules will be there. Because of the high current flow, the particles surrounding the conductor will get ionized. So this ionized. Because of this ionization, what happens is you can observe the hissing noise or some you can observe the hissing noise or some violet color glow, and also it leads to the production of ozone gas around the conductor. Such kind of effect is to be called as corona effect. So it's simply to say, because of current flowing, because this current magnitude is very, very high, because of high magnitude of current flowing in the conductor, right, the particles around the conductor surface will get ionized. will get ionized. So this is going to release some violet glow lighting or hissing noise and the production of ozone gases. Such kind of effect can also be less if it is a DC system. Skin effect will be less, corona effect will be less, and also the dielectric losses will be very less in case of cables, and there won't be any stability problems. All those are the advantages with respect to the DC transmission system. Then what are the even though we are having these many advantages, but what are the major disadvantage? Why we are going to prefer only AC to transmit bulk power? The major problem is, if it is AC, we can step up or step down the voltages using the transformer, but that is not the case with respect to the DC. If you want to boost the voltage or buck the voltage, we need again separate power electronic converters are required. So the transformer cannot do this purpose as it is the DC supply. So this is one of the major drawback. And the power cannot be transmitted at high voltage levels. And also the circuit breakers, all the protective equipments are required. While transmitting this power, just a transformer itself will not be sufficient. So many protecting devices like or switchgear equipment like fuses, circuit breakers, isolators, sectionalizers, relays, lightning arresters, all these things are required in order to transmit the power safely. So all those equipment maintenance will be very difficult if it is to be done with the help of DC. If it is to be done with the help of DC setup, that switchgear equipment maintenance or complexity, construction or operation will be little bit complex, right? They are having their own limitations with respect to the DC. So because of these three major reasons, we are going to prefer or opt the AC system instead of the DC system. What are the three drawbacks, dear students? The voltage cannot be stepped up or stepped down, and the switchgear equipment is having the own limitations with respect to the DC switches, right? And they cannot be transmitted at higher DC voltage levels. So these drawbacks are overcome in the AC system. So the advantages of AC are the power can be generated or transmitted at higher voltage levels. I repeat again, if voltage is high, current will be low, power loss given by I square R will be low. If loss is less, efficiency is nothing but output power by input power, efficiency will be more. This much consequence is there. That is the reason why most of the people will suggest to transmit the power at higher voltage levels. Simple logic, dear students. If 100 watts is there, if voltage equals to 100 volts, what about current? 1 ampere. Power equals to, simple, if it is DC VI. If the same 100 watts, if voltage is 1 volt, what about current? Current will be 100 amps. So observe the magnitude of current with respect to the change in variation in the voltage, right? Yeah. So higher the current rating, higher the power loss. Higher the power loss, less the efficiency. So disadvantages of AC are, as we discussed earlier, if it is DC, only 2 lines are required. If it is AC, we require 3 lines are required. Obviously, it requires more copper is required than a DC line. And construction of the AC transmission lines, huge big towers are to be constructed where these 3 lines are to be accommodated, right? So construction of these AC transmission lines is complicated compared to the DC transmission line, and we are going to have skin effect, proximity effect, corona, skin effect. These are the I have discussed what do you mean by skin effect, proximity effect and corona. These three effects we can observe in AC system. AC system they will be more compared to the DC system. So these are the drawbacks. Coming to the drawbacks, I repeat again, dear students, AC requires more copper. Construction of AC transmission lines is more complicated, and skin effect, proximity effect, corona will be more, and the line itself is going to have some capacitance, so it is going to lead some loss of power. It is going to lead some loss of power, right? So these are the points with respect to the DC transmission and AC transmission. Okay, dear students, once it is decided whether we have to go for AC or DC, next question arises whether the power is to be transmitted using the towers in the form of overhead lines or underground cables, laying the cables in the underground. Which one would be better or preferred? So on different parameters, these things can be compared, whether it is overhead line is better or underground system is better. If it is overhead system, dear students, whatever the lines those are passing there, those are the bare conductors. There won't be any insulation or sheeting on the surface of the conductor. There won't be any rubber or insulating material over the surface of the bare conductor if it is overhead line. But if it is underground cable, the word itself indicates the conductor is to be insulated. Over the conductor, there should be proper thick insulation to be maintained, right? So that is one problem. Now coming to the conductor size. So here, to transmit the same amount of power, the size of the conductor will be smaller compared to the overhead transmission line in terms of diameter. Size in the sense in terms of diameter, how much mm thickness of conductor is to be used. This is for example, to transmit the same amount of power, this much thickness of conductor may be required if it is the underground cable, but the thickness of conductor will be less to transmit the same amount of power if it is overhead line. Similarly, the current carrying capacity is higher current carrying capacity in overhead line and less carrying capacity in underground cables, and it can be transmitted at higher voltage levels because the lines can withstand very high magnitude of voltages. If it is cable, it is limited to not more than 66 kV. So if it is overhead transmission, 400 kV it can withstand. And look wise, if it is overhead, we can easily see the lines. If it is underground, we cannot see them. They will be digged or buried in the ground. The cables will be laid in the ground, and these lines are going to carry the power at some certain frequency. Along this with these towers, these lines are carrying power. Now this power is being sent at some certain frequency, and along with that some communication lines or communication signals, telecommunication signals are going to interfere with this frequency. So in overhead lines there will be the interference problem with the communication lines. If it is underground cable, because they are in the ground, there won't be any interference with the communication lines, right? Now the insulation, very less amount of insulation is required. If it is overhead, it requires more insulation. Of course, the whole conductor will be coated with insulating material, right? More insulation is required, and maintenance is very low in overhead, but the maintenance will be high in cables. Overhead lines are cheaper, but underground cables are very expensive. And for example, if any two lines are to be joined, if any two conductors are to be joined, right, joining the conductors, if it is overhead lines, is easy, but whereas if it is cable, joining two cables is a little bit difficult, right? So it is very difficult. Of course we can do it, but it will be difficult to join the two cables. If it is bare conductor, easily you can join those conductors. And another important point is, for example, while if any electrical fault occurs on the line, for example, if any tree branch has fallen on the line, right? If any two lines got short circuited, now easily we can repair or clear the fault. If any short circuit fault or open circuit faults occur, it is very easy if it is overhead system compared to the cable. The biggest problem is identifying the fault itself is the biggest problem. Out of its entire length, sometimes if it whether depending upon its length, whether it is some 80 kilometers where the fault has occurred, identifying the fault will be difficult, and repairing that is also be difficult. First of all, identification itself is very difficult, and also repairing that is also difficult. So with respect to the fault, identification and clearance, if it is overhead system, it is very easy, right? And we have discussed here, of course, in overhead transmissions, overhead system, we will have proximity effect, corona effect. In underground cables, these effects will be less. And here, due to environment, if any heavy winds are there, lightnings, thundering storms, all those things are going to affect the lines. If any huge big cloud is passing nearby the lines, it may lead to the lightning stroke. But if it is cable, such kind of lightning strokes cannot affect the cable. So environmental impact will be more on the overhead system compared to the underground system. This is one point to be observed. Environmental effect in the sense, if there are heavy winds, these two lines may touch each other. That leads to a big problem. It leads to the short circuit, right? Like that. Similarly, maintenance cost is high in overhead system. Maintenance cost is low in underground system, and the reliability is low. In underground system, the reliability will be high. There is a risk of fire or explosion in overhead system. There is low risk of fire or explosion in cables. And the system, safety wise, overhead system is not that much safer, but the cables, the safety wise, it is much safer, and the flexibility is having high flexibility in overhead, and it is less flexible in underground system. So these are the different parameters, dear students, on which we can compare the overhead system or underground system. And in this video we have discussed, right, different power schemes, AC and DC, and how the power is to be transmitted, either what are the advantages and disadvantages in AC and DC, and what are the comparisons between the overhead line and underground cable, right? Dear students, most of the times the power will be transmitted using a 3-phase 3-wire AC system. Distribution will be carried out using 3-phase 4-wire AC system. Bulk power long distances, most of the times AC will be preferred. Clear? Right. Thank you.